Okay, hello viewers. Welcome to my YouTube channel. My name is Oluwashina Oyinira. In this video, I will be talking about dynamic programming. So, what is dynamic programming? Dynamic programming is a technique used in solving a problem by breaking them into a simpler sub-problems and sorting the result of the sub-problems to avoid redundancy. Now, take for instance, you want to climb a staircase and you want to calculate how to reach uh how to reach this the last level of the stairs. Now, instead of calculating the whole thing, what dynamic programming is going to do is that it's going to break it for you step by step and calculate for the first step, then save the result in the memory, move to the next step, save it in the memory. So what those items you are storing in the memory is going to do is that whenever you have the same problem, it's not going to do any calculation for you. It's just going to recall what you already have in the memory, and that is how dynamic programming works. So I'm going to be using a Fibonacci series example here. So I have a snippet. Let's use this snippet for instance. Now, in this snippet, you're going to discover that I declare a function, and in the function, I have two variables, n, which is the Fibonacci number, and the memory. So, what it's going to do here is that it's going to search, do we have n in the memory? If yes, then return n. Otherwise, proceed with solving the problem. And this is exactly how Fibonacci, dynamic programming work in solving Fibonacci series. Now, I have a code here on solving Fibonacci series, but without dynamic programming. And if you look at it here, I only have this function n, and it's not saving anything in the memory. So this is like a one-time use. Whenever you use this, you cannot recall what you have here. But in this new code, I already incorporate dynamic programming in. So let's run this and let's see. So this is how dynamic programming work. But don't forget that in this code, I use a recursive function. And in my previous video, I told you that a recursive function is a function that calls itself within a program. So let's use another example for this. And another example I'm going to be using is the snapsack problem. So sack problem, it involves selecting item to maximize the total value without exceeding a weight limit. So it's a kind of classic optimization problem. I have a snippet for that as well. So let's explore this. So this is my snippet. Now, if you look at this, so what I have here is a knapsack problem. So what this code is going to do is that it's going to have a dynamic programming table. So it's going to create a table to store the maximum value obtained with a given weight. Now, then it's going to loop through item and capacity to check for item and weight limits. So it check if including the item gives a higher value than to exceed it. And don't forget that we don't want to exceed it, we only want to optimize it. So if you look at this, now we have the list of weights and we have the list of value, and the assumed capacity is 5. So By the time we run this code, it's going to optimize this problem and optimize this and give us what is the capacity. And here we have the capacity of in our uh, knapsack. And this is how dynamic programming. If you have any question, comment, put it on the comment section for me. I'm going to attend to it. If this is your first time of watching my video, please like, subscribe, and share with your friends. Turn on the notification bell for other videos, and you can as well watch my previous video. It's going to enrich your knowledge. So in my next video, I will be talking about uh, backtracking. So see you in my next video.